All right, let's talk about something that could completely change, well, everything. Wireless electricity. We're going to dive into the science, the huge breakthroughs, and what a future might look like if we were totally free from cables. I mean, imagine a world where plugging something in just isn't a thing anymore.
I mean, really think about it. What if you never had to look for an outlet again? No more knotted up cables behind your desk, no limits, your phone, your car, your entire house just powered all the time, through the air. Yeah, it sounds like something straight out of sci-fi, but believe me, it's a lot closer to reality than you probably think.
You know, this dream has been around for a long time. We're talking over a century ago, Nikola Tesla had this massive vision, a giant tower that would power the entire world wirelessly. Now, obviously, that didn't quite pan out, but a little piece of that dream, it's sitting right on our nightstands. The journey from that incredible, world-changing tower to the little charging pad for your phone, well, it really shows you how this idea has evolved.
Okay, so how does this stuff actually work? If we want to understand where we're going, we've got to start with what we're already using every single day. Let's get into the science behind that little bit of magic.
So the secret sauce in your wireless charger, it's something called inductive coupling. Basically, you've got a coil in the charging pad that creates a tiny magnetic field. Then when you put your phone down, another coil inside the phone grabs that field and bam, turns it back into electricity. It's simple, it's effective, but it only works over a really, really short distance. And let's be clear, this isn't some niche gadget. We're talking about the Qi standard, which has made this a global thing. It powers billions of devices, Apple, Samsung, you name it. The success of Qi was a huge deal. It proved, without a doubt, that wireless power could be safe, pretty efficient, and rolled out on a massive scale. It really paved the way for all the cool stuff that came next.
Okay, so charging on a pad is super convenient, right? But it's still, well, you basically have to touch it. The real dream, the one we're all waiting for, is powering things from way across the room. And to pull that off, you need a whole different kind of tech.
And that brings us to resonant inductive coupling. The tuning fork analogy here is just perfect. You know how if you strike one tuning fork, another one with the same pitch across the room will start to hum? It's the same idea but with energy. If you get a transmitter and a receiver vibrating at the exact same magnetic frequency, they're in tune, and that lets the power literally leap across a gap of several meters. It's pretty amazing.
And this is not just a cool theory. Back in 2007, a team at MIT actually did it. They powered a 60-watt light bulb from 2 meters away. That's over 6 feet, with absolutely nothing in between. No wires. That was the moment. That was the proof that this mid-range wireless power thing could actually work, and it kicked off a whole new wave of innovation.
So, we've made the leap from a charging pad to powering something across an entire room. That MIT experiment really opened the floodgates. So now, let's look at how this is being used out in the real world on projects that are already making a huge impact.
I mean, this stuff is already out there saving lives and changing how cities work. Take Gumi City in South Korea. They have buses that literally charge while they drive their route, pulling power right from the road. In the medical world, they're using it to power artificial hearts without any wires breaking the skin, which is a total game changer for preventing infections. And yeah, those wireless charging pads for electric cars, they're starting to show up everywhere.
Okay, so everything we've talked about up to this point, your phone, that bus, that's all what we call near-field power. It uses magnetic fields, and they get weak really fast the further you go. But what if you want to go really far, like kilometers? To do that, you have to switch gears completely. We're moving away from magnetic fields and into far-field power, using focused beams of energy like microwaves.
And this is where things get really wild. It's almost like we're coming full circle back to Tesla's original massive dream, but with the 21st century twist. Just imagine this. What if we could capture the endless power of the sun up in space and then just beam it down to wherever we need it on Earth?
The way this works is through something called microwave power beaming. It sounds complicated, but it's really a 3-step dance. Step 1, you generate power, maybe from huge solar panels in space. Step 2, you convert that power into a super-focused microwave beam. And step 3, on the ground, a special antenna, and this is a great name, it's called a rectenna, catches that beam and turns it right back into electricity you can use. Simple as that.
And again, this isn't just on paper. Back in 2015, Japan's space agency, JAXA, pulled this off. They successfully beamed 1.8 kilowatts, that's enough juice to run a microwave and a toaster at the same time, over 55 meters. It was a huge proof of concept. It showed they could aim the beam precisely and that the whole idea was actually workable.
But the real, honest-to-goodness historic moment, that happened just recently. In 2023, Caltech sent a satellite up, collected solar power in orbit, and beamed it all the way down to a receiver here on Earth. It was the first time ever that space-to-Earth wireless energy transfer had been demonstrated. Think about that. We just proved it can be done. The door to a completely new future just got kicked wide open.
So we've covered the science, we've hit the major milestones, and we've seen some absolutely mind-blowing potential. So what does it all add up to? What would a truly wireless world actually look and feel like?
Honestly, the possibilities are just staggering. Picture this: highways that charge your EV while you're driving on them, drones that never have to land, that can just stay up in the air forever. Or think about being able to instantly send power to a disaster area after an earthquake or a hurricane. And of course, the big one, a truly global power grid running on clean, endless solar power beamed down from space.
Now, let's be real. We're not there tomorrow. There are some major hurdles to clear. We lose power over distance, so we need to get more efficient. Safety is absolutely critical. You can't just have high-power beams zipping around without perfect control. And the cost? Building all this, especially the space stuff, is going to be incredibly expensive. These are the big problems that scientists and engineers are working on as we speak.
So I'll leave you with this final thought. For more than 100 years, our entire civilization has been built around a web of physical wires. It shaped our cities, our homes, our entire way of life. So the big question is, what do we build next when we're finally free of them?